if on our preview here, if we plus the 2, 19 plus 2 is 21, what's my last step going to be? Okay, divide by 3. Okay. And I will make a reminder at this point, because it'll be real important for some of you when you do get to the quiz tomorrow. I've got to see at least a step of something. I'm purposefully trying to make these a little bit simpler, just so we can get the general idea of this down. Okay? So, I'm not going to have this where you just put x equals 7, because you kind of get some mental math and plug some numbers in. Okay? Tyler, that needs to be out of your ear, please. Thank you. Okay? Same idea here, working on 2. I need that fraction by itself first. How do I get rid of what's not in the box? Minus 6. Thank you. Okay, let me answer that, because that's a good question. Okay, because I will have some people, because a lot of times we do get rid of the fractions first. So somebody may say, can I multiply by 3 first? And you could, but here's the reason I wouldn't. If I have to multiply by 3, I'd have to multiply the 6 and the 12. And sometimes we forget that. So it's a little bit easier to get that taken care of first. Now what's my last step to get x by itself? Multiply by 3. I'm starting to hear more of you, which is good, which means this could go really, really well tomorrow. Multiply by the 3, and we're there. Yeah, at one time or another during the problem, we're going to multiply to get rid of that fraction. That's absolutely correct. Now, 3 is kind of our weird one up here, because I have multiple terms with x. But here's the thing I have to keep in mind. Somewhat, they're on the same side of the equals, but I do have to watch the signs that are in front of them. I've got 4, but that's negative or minus 6. So when I put together 4 and negative 6, what do I end up with? Negative 2x. Again, think of it like money. If I got $4 and I go spend 6, now I'm 2 in the hole. And now it looks more like what we normally are doing in all of these. Yep, I'm on. What is the first one? Back to our regularly scheduled programming. All right. So, oh yeah, I'll mention that. Some of you are wondering what the heck I'm doing. A couple of you are new here. I video, well, what you see up here video, not like video all of the lessons and end up putting them on the website online, so if people are ever gone or have questions and things like that, they can always go back and look at some of these. So that's why when I'm sitting here and I'll pause something and like, what's he up to? That's basically what I'm up to at that point. Okay, back to it here. How am I working on getting my x by itself? Okay, minus that 6 out of there. Correct. Correct. And I'm glad you're kind of thinking about that. Because what's my last step here going to be? Divide by negative 2. And right, when we're talking about inequalities, like if this were one of the problems from 7 through 12 down at the bottom, then I would have to flip the inequality arrow. But since it's just equals, we have no inequality arrows to worry about. So we'll just leave that one be. All right, so far so good. Move up here a little bit. All right, for 4, what's up next? Okay, again, whatever's not directly connected to my x, that's got to go first. Ooh, fraction. Now what? Okay, if I want to just take care of the whole idea of a fraction there, I can multiply by 5 here. But that still leaves me with that 2 up in the numerator. And then just divide by 2. Everything is just a step-by-step process work my way through towards getting that x by its lonesome by the end. That's all we've got working. One stepper on number 5. What's the one step? Okay, divide. Again, that minus that I see isn't between the 3 and the x, it's over here, which means I'm multiplying. The opposite of that is divide. What's a negative divided by a negative? Positive. Okay, so just little detail things that we're trying to take care of. Okay, so on 6, now it's a little different of a situation. Because if we compare it to number 2, well, there we did the adding and subtracting first, but there's a difference. This time, it's one big fraction. So I can't subtract the 7 first, because it's part of this whole thing. That's right. This time, since it's a big old fraction, I've got to multiply by the 4 first, because I can't get to the plus 7 until this part's gone. And that can be a little bit interesting at times, trying to figure out. Last step. Subtract the 7. And be cautious. Think money if you have to. I spent $12. I spent 7 more. How much did I spend? If you can get to a point where you can take equations like this and manipulate and work your way through them and not have a lot of issues, basically you've got the main point of Algebra 1, because this builds everything. Whether we're doing equations and we're graphing, or we're just doing this, or we're solving story problems, everything's got to do with equations sooner or later. So that's why we kind of keep pounding away on these and pounding away on these. So then we move to what we've been doing the past few days, okay, with the inequality. Solve them just like you would an equation, except with a couple of minor little tweaks here and there, which we'll note here in a minute. Okay, what's my one step to get epsilon in number 7? Okay, minus the 8. Then there's a couple of quick things we got to talk about here. All right, so once we get into here, scooch this over a little so I can fit this. Remember, when I go to graph, if it's just less than or greater than, I'm going to have an open circle. If it's or equal to, that circle's going to be colored in. We'll kind of take things in little bits and pieces here. So for instance, we know that we need 3 numbers and that our answer, once we figure it out, okay, and that's what we were just going to hit up here. When I'm trying to figure out, well, is this greater than or less than? Because I know it's an open circle, because there's no line underneath. How do I figure that out? And here's, again, how I want to look at it. Because I don't always want to trust that this arrow is necessarily telling me the way I have to go. So here's what I always like to look at. When I'm looking at x, and it might be written either of these directions, but what these two things have in common is the arrow is eating that x each time. Okay? Whenever that happens, that's when we're going to have something that's greater than, and when that happens, the arrow goes to the right, because my values get greater on a number line as I go to the right. However, if that arrow is pointing at my x, okay, in either direction, that's less than. And the arrow is going to go to the left. So that's the way I like looking at it, just to kind of make sure I can keep it straight no matter where my x is going to be. Eat the x is bigger, okay? Kind of think of it that way. When you eat something, you know, weight goes on here. It can get a little bit bigger. So it's greater than, but if the arrow is pointing at you, kind of less than, it's kind of like, ooh. So what way is my arrow going to be going for number 7? Arrow's pointing at x. That's okay. Arrow's pointing at x, which is less than. So my arrow's got to go to the left. I have to put the arrow in. You have to let me know which way we're heading with this. Same idea is going on here with 8, but got a little work to do to get x alone this time. What's my first step going to be? Subtract that 13. One step to go. And divide by 3. Okay, so let's see. 5, 1 more is 6, 1 less is 4. And again, the order matters here. So in a number line, your values always go greater as you go to the right. So since 6 is bigger than 5, it's got to be to the right of 5. If 4 is less, it has to be to the left. So let's see. You know the 2 questions that are coming. Open or close circle, and which way is my arrow going? Oh, that was almost like stereo. Okay. Close circle, greater than, head to the right. Good deal. One stepper for 9. Multiply. Since I'm dividing by 9, we'll multiply both sides by 9. $27 will go in the middle. $6, $27, $28. What are the answers to my 2 questions that I ask every single time I move? Open circle, arrow's eating the x, which is greater. Off to the right we go. And if you're not sure sometimes, you can almost think of it as, well, what if I plug the number in? You know, is 26 greater than 27? No, so I don't want to color on this side. There's some other little ways you can kind of check when you're working through inequalities to make sure you're doing it right. All right, down the home stretch we come. What do I need to do first on number 10? Okay, add the 10. I got to get that minus 10 out of there. Okay. Divide by -4. Yep, and here's our one last twist. When I'm doing inequalities, and Eric mentioned this earlier when we were up in the equations, if I divide both sides or multiply both sides by a negative to get x alone, that's the one time that I've got to flip my arrow. Okay. So if I divide by a negative, get x alone, I have to flip the arrow. Because otherwise, I'll get the exact opposite of the values that I'm trying to get. Here's our first issue with this, too. I put all sorts of fun little pitfalls here. I know -6 goes in the middle. All right. You guys hit each one on each side. When we're doing negatives, the number line looks kind of weird. So you're like, well, 5 is bigger than 6. But again, when you're in negatives, almost think, would I rather owe somebody $5 or $6? I'd rather owe them 5. Okay, that's less money. That's what I have to think about when I'm doing this for negative. So, close circle, we have or equal to. Which way are we heading? Right. Alright, so now 11, kind of like number 3 was up above. I have x's on the same side combined. 9 minus 8 is 1x. You could, and the only reason that I normally don't get rid of the 13 first is then sometimes people get confused with the x's for some reason. But you absolutely could do that. You absolutely could. Because you'll end up with the same answer here in a minute. Because what the rest of us, what's our last step going to be? And minus the 13. Again, keep thinking money with this. I spent 4, I spent 13 more. Negative 17. And notice, just because I see a negative number doesn't mean I'm flipping things. Only if I'm dividing or multiplying both sides to get that out of there. Yep, divide or multiply both sides by the negative. That's the only time that we're going to end up having to mess with that. And again, when we're in the negatives, just keep thinking, what would I rather owe somebody? I want to owe them less, so I'm going to go on the right. And I'm on quite a run here of arrow to the right. It's, again, we're greater than, arrows eating the x, we're heading to the right. Gracious. Here, though, we've got a little distributing to do. Remember that 2's got to go to the x and to that minus 5. Negative 10. Now we're back in the same situation we have been on so many of these. Plus the 10. And divide by 2. Again, we just want to keep working from what's furthest away from my x until I get, whoops, and Harty has moved itself off the screen. Okay. And you're right, I've got yet another one to the right. And another one that's colored in, so we have the order equals to. So basically what you have in your hands here is a copy of the quiz we're doing tomorrow. There will be 12 questions, there will be 6 equations, there will be 6 inequalities. Okay? They'll be set up in the same type of way. So if this is something that, you know, you either got a spot that you're struggling or you're like, I get it most of the time, but I just, you know, take this maybe tonight and maybe just jot a couple of problems down, see if you can do it without looking. Just to kind of get yourself thinking about it a little bit. No. No. Now, we will end up getting to some of that because in the next unit, we're going to start doing things with slope and graph and lines, and we will be getting more into the white. Well, I want to throw a couple of those in there just to think about that a little bit.